Hello, stats class. Here's lesson 9-2B. So we have done a lot of different steps. We're going to do the 4-step process today. But I want to remind you that we've already done most of these steps. So we did all 4 steps when we did confidence intervals, and we did in lesson 9-1, we did the state and the conclude. We learned how to do those 2 steps. In 9-2A, we learned how to do the calculations part. And we've actually known how to do the plan ever since chapter 8. Chapter 8, we did the plan. Today, we're putting it all together. So 4 significance tests. How do you do the whole process? And that's where we're headed today. So we're going to combine all of this today into the full 4-step process. Yay! So we're going to use an example that's familiar to you because we've already done it. The potato chips. We'll take a different sample this time maybe, but remember the potato truck arrives at the potato chip factory and they gather some data in order to determine if these potatoes are good enough to make our excellent potato chips. And recall that we said that 8% blemishes was okay and more is not okay. And so that's what's going to cause us to reject the truckload, or if we reject the null that says that this is 8%, we will reject the truckload. So that's a review of what we've just been doing. So that data gathering process is a random sample of potatoes off of the truck, hopefully not just the top whatever potatoes, right? But we're going to take a random sample. We want it to be a pretty big random sample because a truckload is a lot of potatoes. So we're going to say we're going to take 500 potatoes, and that's our random sample. I know that's really big on purpose. And let's say we got, actually I'm going to say potatoes. And let's say we got 47 of them have blemishes. Or potatoes with blemishes, either way. So that's our data. This is evidence, maybe for, maybe against. I could actually find the sample proportion from that. So p hat, a little off to the side, is p hat is 47 out of 500. And we might want to actually know what that number is before we go on. Because if it's under 8%, we're just not even going to do the test, right? 47 out of 500 is 0.094. So we're wondering if we should reject or not reject. And since this is a different sample size than we were using on the warm-up the other day, we have to go through the calculations because this might come out significant or not. We don't know if that 10% cutoff is going to work with this sample size. So we're wondering, is it strong enough to reject? Or another way of saying that, which I think is kind of fun, is you could say strong enough, or you could say, is this weird enough? Is this sample weird enough compared to the 8% that we think is true to reject this truckload? So that's where we're headed. I'm going to go through all 4 steps. And I'm going to do it kind of in a 2-column thing, except that my first column is going to be really narrow. So if you want to draw a dotted line, you can. It's up to you. I'm going to put the generic over here and the specific over here. So we've got state, which just like in chapter 8, we have to say what our parameter is. Instead of a confidence level, we're going to have a significance level, alpha. And then the third thing that we actually learned in lesson 9-1 is how to make our hypotheses. That's something we didn't need in chapter 8. In chapter 8, we did not have a theory about what we wanted to test. We just were trying to estimate. So that's the big new thing in chapter 9 is we're doing a hypothesis. Sometimes it's called a hypothesis test instead of a significance test. All right, so we're going to do those 3 things over here. So my parameter is might be this 8%. When I'm defining my parameter, I'm not going to put the number in there. I'm going to say P is the proportion of blemished potatoes in the population, which is the truckload, so notice that it is not P hat, and it is not about this population, because this is not a population, it's a sample. So this is not the parameter, this is the statistic. The parameter is the true proportion, you could even say that if you wanted to, of blemished potatoes in the whole population. And we think, that's our null hypothesis, we think that that proportion might be 0.8. Actually, remember the null is dull. 0.08, not 0.8. 0.8 would be 80%, so be careful about that. The null is nothing weird is happening here. It's 8% and it's fine. Alternate is the interesting situation. If it's more, that's what would cause us to do something. So this is the more than 8%. You could write a less than or equals for this if you prefer, but you definitely want the equals part to be on the null. Null always is the equals. Null is dull, always equals. Sidetrack, because some people missed that on the quiz. Don't ever put the equal sign in the alternate. The alternate is what if it's not? And that would be, in this case, greater than. And then I forgot to put the alpha significance level, so I'm going to stick that in here somewhere. Alpha is 0.05. We're just going to use the typical alpha, and sometimes they'll tell you not to. That's the state step. And it's a lot like what we did with confidence intervals. We still have to have this and this, which is almost like a confidence level, but this is the new piece. This is the piece that we learned how to do in 9.1, and it's really important that you get those hypotheses right, because that's what we're testing. All right, number 2 is plan. So you might remember from chapter 8 that in the plan, you're supposed to name the procedure. This is one that I haven't made a huge deal out of yet, but it's getting more and more important because this is our third procedure we have learned, and so we need to say that this is the one we're doing. We're also going to check the conditions, and the conditions are awfully like an awful lot like chapter 8, so that's kind of good. So checking the conditions and naming the procedure. Naming the procedure, the thing we're learning how to do is a test for a proportion. And the book calls it a one sample z-test or something like that, or one proportion z-test. You know what? You need the word test instead of interval, and you need the word proportion. Those are the two important words. And then the same 3 conditions that we learned in chapter 8, we're working on what we learned before, the same 3 conditions as before, random. We check to see if it's given. Oh, look, it says that it was a random sample. So I'm going to just put a little arrow and say this is yes because it's given. It will almost always be given. Normal, here's where it changes a tiny bit, because with the confidence intervals we used p hat. I'm going to put that over on the side. The confidence intervals we use p hat. With the hypothesis tests or significance tests, we use the number from the hypothesis, which that 8% is officially called P0. So that's going to be one little change that we make. We're going to go NP0 instead of NP hat because we don't want to know the number of successes in our sample. We want to know the expected number of successes. So this number comes from our null hypothesis, and N is 500, and P0 is 0.08. So I'm checking to see what the expected number of blemishes is in my sample. This comes out to 40, which is bigger than 10, and that's good. And then I'm also going to check NQ0, also from the null hypothesis. So 500, I mean, times 0.92, that's 1 minus the 0.08, and that's a lot bigger, obviously. Technically, you don't have to check both. You could just check the smaller one and say this is bigger. but I check them both just to be sure. So this is a yes, because both of these are bigger than 10. So you're always going to have your answer to the question and your justification. Justify why. It is really important that you justify in this class. All right, the third one is independent. It works the same way as in chapter 8. I hope you already have these three things memorized. Independent, it depends on how big the truckload is, but I'm going to assume this is a huge truckload. So I'm going to say yes, because I am going to assume that 500 potatoes is less than or equal to 10% of all the potatoes on this truck. So we're talking about a semi-truck. We're not talking about a pickup truck, right? On a large truck. And if that's not true, or if you thought it was not true, it's okay to say that. It's okay to say, well, I'm not sure that this is true, but I'm going to continue anyway. So that's the conditions. You should already be able to do this, except the main change is that the P0 instead of P hat. So that's kind of a one little detail. Step 3, do. Where I have somebody who likes to say accomplish for this, because then it spells SPAC, which is kind of fun. If you want it to spell SPAC, then you say accomplish. But anyway, this is where you calculate. And instead of calculating an interval, we're going to calculate our z-score and our p-value. The z-score is also called the test statistic. It's a statistic because it's calculated from the sample, but it's the one that we're using to test this hypothesis. So that's one of the names for the z-score that we're about to calculate. So we learned how to do this in lesson 9.2a. In fact, I should have put A up there. In 9.2a, we learned how to do the calculations of the z-score, and so let's do that. On the AP formula sheet, they write it in words, and then you have to fill in the numbers. And so I'm going to give it to you both ways. They say it's the estimate minus the parameter over the standard error. Actually, it's not called standard error in this chapter. It's called standard deviation, because we're not going to estimate it from the sample. We're going to use this p-value. So standard deviation, not error technically, because we'll use P0, not P hat. So there's another time that we use P0. In other words, if you think you know what the true value is, or you're testing to see if it's that true value, use that value in your calculations. It'll be a little more accurate that way. So in proportions, which is what we're doing right now, the estimate is called P hat. The parameter is called P0. That's the hypothesized parameter. Divided by, we're going to do the standard deviation using that P0 and Q0 and N. That is the formula for proportions. By the way, if you don't put this, if you leave that off by accident and you put this, it counts as naming the correct procedure. This is proof that you know which procedure you're supposed to be doing. So then fill in the numbers. P hat is 0.094 minus 0.08 divided by, I'm going to do 0.08 times 0.92 divided by 500 and square root it. So my minimum amount of work shown would be this right here. Please show this step to show that you know what you're doing. And then you can pick up your calculator, and that's fine. So I'm going to actually do the bottom first, because I'll show you why actually. 0.08 times 0.92 divided by 500, and then square root it. And I'm going to write that down. I guess you wouldn't have to show this part, but I find it easier to do the top and bottom separately and then write them down and then divide them. So this came out to 0.014. Maybe I'll add a few more digits onto this for accuracy. And divide by that number. If you want it super accurate, you use all the digits. I got 1.154. I wonder how accurate it would be if I rounded. Let's just find out, because some people are not aware that rounding off makes a huge difference. That's 1.16. And if I put a few more digits on it, then it's 1.154. That's pretty accurate, so I'm going to go with that. All right, and then to find, so that's my test statistic, and then to find the p-value, we do normal CDF or use table A. And which direction are we going? Let's picture this normal curve thing that we're thinking about. In fact, if you draw it, that's awesome because then it shows me that you know what you're talking about. So 0.08 is in the middle. 0.094 is over here somewhere. And we want to find this area. That area right there is called the p-value. It is a one-sided test because this is greater than. So it's a one-sided. We only have to do one side and not the other side. But the way I know that it's greater than is partly because this p hat is bigger than my hypothesis, and partly because that's my alternate hypothesis, that greater than thing. So basically, normal CDF, I need to go from this value up. And that would look like this. Normal CDF, 1.154 and 999. Leave these alone always. Basically, if you wanted to, you could skip this step, but if you did that, you'd get marked down on both the AP test and my tests and my quizzes. So don't skip the step where you're calculating the z-score. That's why I haven't shown you how to make the calculator do that. 0.06. Well, that's interesting. I got a different answer last year, which bothers me just a bit. Oh, I know what happened. I typed my z-score wrong. Let's fix that. It was 154, not 54. So let's fix that. I would like it to be the right answer. 0.124. So let's think about what that means. Remember, the p-value, what we just calculated, is officially the probability of getting this p-hat value that we got of 47 out of 500, this 0.094, probability of it being greater than or equal to that value, given that the true value is 0.08. Sometimes you'll be asked to explain that as part, in fact, maybe I'll write that as part of my conclusion. Sometimes you'll be asked for that and sometimes you won't, but this is what it means. We just found the probability of getting this large amount of blemishes or more, given that this is true. And since this came out not too surprising, we're not going to reject this time. So 4 is conclude. The conclude step we've talked about, but I'm going to make it even more specific. I'm going to say you will always have 3 parts. You will always have a decision and a justification and a conclusion or a context. Don't forget the context. So I'm going to give you an example right here of how to do that correctly. I usually like to start with the justification, which is since P is 0.124, and I notice that 0.124 happens to be bigger than my alpha value. That's my justification. So you're going to justify by connecting this p-value or comparing it with your alpha. So you should have a comparison in your sentence somewhere. Since that is true, remember I said never say accept. We're going to say we do not reject. The null hypothesis that, so that's my decision. I'm trying to see if I can do this without messing up my work too much. This is my decision, do not reject. The null that, now I'm going to do my context. So the null in context is that the proportion of blemishes is 0.8, or 0.08, the 8%. That the true proportion of potatoes with blemishes is 8% or less, technically, we're not rejecting the idea that this truckload is just fine. And then we could even say we have no evidence for the alternate. So this extra sentence is kind of extra and optional, but makes you sound good. We have no evidence that this truckload is bad, or we have very weak evidence that this truckload is bad, but not enough evidence to reject the truckload. So we'll use it to make potato chips. So this is a statement about the alternate, and it is sometimes more important than others. Basically, it's more important if you're rejecting, to say, because we rejected this, we think the alternate must be true. If the alternate's not true, they usually don't have that in the rubric, but it's a good habit to get into. Oh, I meant to say HA. Sorry about that. Statement about the alternate. What are we concluding? We just said we don't reject the null, and the alternate, we don't have any evidence for the alternate. Okay, a couple more details. Never say except. Why not? If we were in class, I would make you tell me why not, and hopefully somebody would come up with it. Remember when we did confidence intervals, we said we're pretty sure the true value is somewhere between here and here, but we're never going to pin it down to we are positive it is exactly 8%. No, we're not going to say we're positive exactly 8%. Even though we're not rejecting it, it might not be exactly 8%. It's just close enough. So those are bad words in statistics, and you will always get marked down for those, both on my test and on the AP test, if you say accept the null or say that you know that the null is true. That's being way too certain. So accepting is just being too certain, and we can't do that in statistics. And then the other thing is sometimes you'll be asked to interpret the p-value, and that would be writing a sentence about this statement right here. So I'm going to put that at the very end. You would sometimes need to do this depending on the question. If the true proportion is really 8%, then there's a, 12.4% chance of getting a sample with our p-hat is 9.4% or more bad potatoes. So that's a reminder of what we did in lesson 9.1. All right, that is more than enough notes for today, and the next notes will be shorter, I promise.